only thing I'm going to do in this section, even though I already have all the comments on every single line that I've written, I still think it's a good idea for me to go through and explain simply what the entire section is doing. So for example, this is going to be the very first thing that runs in my code, right, in my program. So I'm going to copy this into my Word document, and I'm going to explain everything that's happening in here using a paragraph, bullet points, whatever you deem fit. Just make sure it's detailed enough. For me, I might do a mini paragraph for each one. So this is the first thing that runs, and if this button is pressed, it jumps to that function, and I'm going to go to that function and explain exactly what happens inside that function. And if the other button is pressed, I'm going to go to that function as well and explain what happens there. And I'm also going to explain the keyboard interrupt here. So that's all this section is going to be, is me explaining what happens in each section. So all I've done in these sections here is I've gone ahead and I've explained why exactly I needed to do from machine import pin, from import utime, from machine import I2C. That's all I've gone ahead and explained here. So for example, the first one, I'm not going to read this entire thing here, but the first one, from machine import pin, simply allows me to import pin functionality, which then allows me to make use of the pins on the Raspberry Pi Pico to either make them input pins or output pins. So I can then connect input devices such as, in this instance, the hall sensor, or output devices such as LEDs, buzzers, so on and so forth. So that's what the pin functionality allows me to do. Utime simply allows me to sleep or pause the program. It doesn't have to be utime. You could use sleep as well, but utime seems to be the one that most people use for MicroPython. But sleep would work exactly in the same way, and so on and so forth. So all you have to do for each section, again, is go through and explain what's happening. For this section down here, I've explained that, okay, LED, for example, is the internal LED. It's connected to pin 25. That's a fixed pin, by the way. So let me put fixed in brackets here, FIXED, and it's fixed because it's obviously made onto the Raspberry Pi Pico. Pin 17 and pin 16, green LED for pin 17, red LED for pin 16 respectively. That's what I've said there. The buttons left and right are connected to pin 14. Now these are set to pin in input pins. Oh, one thing I left off. These are also connected to the pull down resistor, resistor, as this forces the buttons to always be low because it's a pull down. It pulls it down to the 0 volt or the ground rail. If it was a pull up, it would always be high. The buttons to always be low until they are pressed. This is just one of those safety precautions that just ensures that there's no weird spooky action going on. That's all that is. Again, all I've done here is I've explained what I've connected it to and why I've connected it to that. For example, down here where I have the LCD stuff, so this, let me just move this down a bit. I've said the SDA and SCL are pin 4 and 5 because on the Raspberry Pi Pico, those pins can do serial data. Well, SDA in this case, and SCL can do serial clock. So it had to be either pin 1 and 2, 4 and 5, I think 6 and 7, so on and so forth. But you have to use specific pins. You cannot just use any random pin for SDA and SCL because the Raspberry Pi's datasheet, if I can bring it up here, here we go. The Raspberry Pi's pin out tells you exactly what you can connect it to. So let me drag this over, and as you can see, SDA here and SCL here. I could have used pins, well, GP0 and GP1, but I just use 4 and 5 instead. Why? No specific reason, just because it was there and I can use it. Now, there are other pins that you can use. I'm not going to spend too long on that, so that's why that was done. And I've simply, again, gone in and explained some of the stuff here. Now, for the LCD specifically, there's not too much you need to say about this part, simply because the files that were given to us, obviously, we didn't create them. Right? I don't know how to sit down and program driver files for an I2C communication device. I don't know how to do that. So I found the files online. I copied them onto my Raspberry Pi, and those files, they had, let's say, a mini data sheet connected to it. So it helped us to easily program or send instructions or commands or text to the LCD using an I2C adapter. That's it. Now, all you guys have to do is pause this video and read through everything. I don't want to read through everything now because it's going to make this video very, very long already. So the way I'm going to explain things is in the order that they happen or the order that they might happen. And this is the very, very first thing that happens when you run my piece of program. So it gives you a mini countdown and it puts it both on the LCD and on the shell as well. So the LCD is obviously the liquid crystal display connected to the Raspberry Pi Pico, and the shell is the Thonny section at the bottom where you see the outputs. It puts it in both locations. So whoever's using the system, whether it be me, the developer, or someone in a factory using the system, I will know what's going on. So when I see 3, well, it says starting in 3, starting in 2, starting in 1, then it says ready to start. I know as someone in a factory, oh, I should probably press the start button now, because my manager who gave me some training told me, oh, it takes roughly 3 to 4 seconds to start up. And when it does start up, all you have to do is press the start button. That's all that this section does. It just adds to the user-friendly nature of the system so that someone who's using the system has some indication as to what's going on. Please pause and read this section. This is the very first thing that happens in my program. I'm going to screenshot this instead and put it into my document. That might be a bit easier to have everything just looking all right. So I'm going to do Windows flag, Shift and S on my keyboard brings up the screenshot option. And I might just do this section here first, as that might be easy to explain. So this is going to be the first I explain. I'm going to go back to my Word document now. I'm going to paste this in here and simply explain what happens here. You could do it at the top or at the bottom. So I might say something along the lines of, a while true loop is created in order to have this run forever. Right, so that's what the while true loop does. It runs forever. Inside the while true loop, there is a try statement, or a try block, you could say. And what the try block does, it prevents the program from crashing. So whenever you try something in a while true loop, it's just going to keep trying that thing again and again and again. Let's just say, for argument's sake, I did a while true loop, right? And I just put the if statements in there. If the if statements were not true, it might keep going again and again and again. But in some cases, what might happen, if the condition is not met inside the while loop, it will just crash. What the try does, it tries it, and if it doesn't work, it just keeps trying it. Where there's a try statement. The first, I'm going to separate things like bullet points kind of. The first if statement checks if the button left value, if the left button, or let me put it at the same name, button left has been pressed. If it has been pressed, now keep in mind, if something has not been pressed, we don't care. We just leave it as it is. We could put elif or if statements in to double check as well. If it's not pressed, say, well, you should probably start the system now. But it really doesn't matter. We only care when the state goes from 0 to 1, or from low to high, or from off to on. That's the only thing we really care about. A while true loop is created in order to have this function or this section run forever. Inside the while true loop, there is a try statement. And again, the purpose of the try statement, if you want to state that as well, is to ensure that the program doesn't simply crash if the condition that you're looking for isn't met the very first time. You want it to just keep trying and trying again and again and again, checking if that condition is eventually going to be met. The first if statement checks if the button left or left the button has been pressed. I labeled it button left, button underscore left, so I'm using that same name here. If you labeled your button or your switch something else, obviously you call it that name instead. If it has been pressed, there's a message on the shell, and the shell, let me just go back to my thing here. This is the shell down here. This is what I call the shell, not what I call it. This is the actual shell. So I just say there's a message on the shell or screen of the computer, start pressed. The LCD is cleared. This needs to be done to remove all the previous content which might have been put to the LCD. So the LCD here has this weird thing where if, let's just say for argument's sake, I write to the LCD, stop pressed, hello, my name is Bob, 1, 2, 3, 4, 5 on separate lines, what will happen? Everything will get jumbled up. So before you write to the LCD for the Raspberry Pi Pico, you should clear the LCD first. And to clear the LCD, simply then the name of the LCD, the variable name, I just call mine LCD, makes it very simple, lcd.clear, and that's it. It clears it. Then I simply do lcd.putString. The LCD is then populated with the statement start pressed as well. So the LCD and the shell, so again, this is the shell down here. The LCD and the shell have exactly the same message put on them. And when I ran my program in the previous video, you saw that they were both showing exactly the same thing. The program pauses for 0.2 seconds and it calls or runs the function named main running. Now, I've called my function main running. You can call yours whatever you want. Probably not the best name in the world, but it works. This is the main section of the code which causes the system to operate in the desired way. Now, this is just explaining what this section of code is doing. When I get to the main running function, I'm going to explain again every single thing that's happening in that function. So that's why I've left it very vague here. The second if statement checks if the button right, this should be underscore here as well, if button right has been, let's put this in quotes, if button right has been pressed, if it is pressed or if it has been pressed, the same message is displayed on the screen or the shell of the PC and the LCD. The message is stopped pressed. Again, the LCD needed to be cleared before the text could be put there, as it would be jumbled with the previous text. The program then sleeps for 0.2 seconds and finally calls or runs the function named stop running. This function is used to mimic an emergency button being pressed. So again, as I mentioned, let's say someone's, not on this particular one, but in general, you're in a factory working, someone's hand gets stuck somewhere, the machine is doing some weird thing, is spitting out too many things, or it's moving too slow, or it's catching on fire, whatever the case is, and you want to stop it. Ideally, you don't want to go and touch the plug. There's normally a big or multiple big massive red emergency stop buttons on the machine itself. So when you tap them or press them or kick them or punch them or whatever the case is, it's going to stop the entire machine. So that's what this function for me represents. Now this section here called the except keyboard interrupt, the final part of the while loop and try block is a keyboard interrupt. This simply listens out for the stop button to be pressed. So on funny, that red stop button there, you might not, I'll try and zoom in as best as I can, that if I run this program and I press the red stop button, that's what the keyboard interrupt is. I could make it so that I press a specific key on my keyboard as well, but that's probably the easiest thing to do because there's other inputs going on here. If the stop button has been pressed, then output devices are all turned off to mimic a machine being unplugged or told to stop its operation. The devices which are turned off are the buzzer, red LED, green LED, the internal LED, and the LCD's contents are cleared. So that's why I have buzzer.low, red LED.low, green LED.low, LED.low. So the buzzer is turned off, red LED is turned off here. Let's zoom in some more, sorry. Green LED is turned off here. The internal LED is simply called LED. I turned that off here. And the LCD is cleared. Well, I left out something as well, actually. So I need to say print the good count and bad count. The good and bad count are also added to the shell, not the LCD, just the shell. This shows the number of good items there, well, good and bad items there were. Done. That's it. Right? So it's not the most detailed or but it is accurate, right? Now, you don't have to use any fancy words here. Simply explain what's going on in as simple terms as possible so that anyone that picks this up can read it and understand, okay, that's what they're trying to do. They might not understand the Python code itself, but they should at least understand what you've explained here. The way I've done mine again is I just screenshotted it so that it keeps the same format. Now, I would highly recommend, suggest, and tell you, you need to copy in the entire code as well. So when I'm finished explaining everything, when I go through every single section, I'm just going to come in here, highlight every single thing. I can just do Control A. So on your keyboard, press Control, hold it down, and then simply tap A, and it highlights everything. I'm going to come in here and copy all of this and paste it into that Word document at some point. But just for explaining what's going on for each section, I might as well do the screenshots. It still looks very neat. It's all lined up in the comment section, and I can explain it very easily. If I copy and paste my code and try to explain it, it gets very jumbled. So if I go ahead and let's say I copied this section here, just showing you why I'm not doing it this way. When I paste it in, if I want to explain what's happening here, this is going to be very tricky. So I'm doing the screenshot method. That might be a good option for you as well. If you prefer to paste your code in and then type and talk about it, that's fine. Whatever you decide is best. I'm simply trying to show as many options as possible so people have, well, options to work with in the exam and don't think, oh, this looks really weird, I have to do it this way. No, I would screenshot it, explain it, but if you prefer to do it the other way, that's perfectly fine. So let's just say, for argument's sake, my program starts to run. The very first thing that should ideally happen, the person should press the button to actually start the system. So let's go to the function called main running, because I've explained all of this section already. So my main running function, now with functions, again, please note they have to be at the top. So before you actually use a function, you have to create it. So let me just do an example again. Let's just say I wanted to call a function and that says print my name is Bob. I have to define the function at the top first, print name, for example. And inside of this function, I might say print, and I might say my name is Bob, right? Before I use this function, I have to create it at the top. So now that it's been created, I cannot call that function here at the top call. Let me just copy this. If I put print Bob here at the top, this will not work because the function must come before I use it. So this is how I create the function, and this is how I use a function. So for me to use this the correct way, let me get rid of that. It must be after I've created it. So again, this is the creation of the function, and this is how I call or make use of the function. So this is why in my code here, I have the functions being called at the very, very bottom of the entire code, and the actual functions being created at the top. So here I have main running function at the top, well, before it's being called. So let's just say, for argument's sake, let me go back to this, sorry. The program starts to run and it tells the person, okay, you need to press one of the buttons. It's going to come to the main running function first. And what's going to happen is it's going to go through the series of steps here. I'm going to screenshot these sections again, put them into my Word document, and try and explain them in as detailed a manner as I can. That now was everything for the main running function. So my apologies if it's just too long, but I wanted to show every single thing, every single step. Now my code already has, again, comments on every single line, so mine is a bit easier to understand and read straight away. Please ensure that you comment as many lines as possible. You don't need to go overboard like I did. Like you didn't need to, for example, comment both these lines. You could have commented one and it would have been implied that the other thing that looks exactly like it does the same thing or does a similar thing. But again, I decided to go overboard just because. Now the next section I'm going to focus on, so that again was the main running function. I've explained everything. Please slow the video down, pause the video, go back and read everything. I will share this Word document at some point as well. The next thing I'm going to work on is a function called stop running. Much shorter than the previous one, but more or less the same thing. It just makes some noise, flashes some LEDs. That was a very long video. My apologies. I will speed it up so you guys can simply read what's happening. Pause when you need to pause. I'm not going to read the entire thing. Just pause it and read what you need to read. This now explains every single section of my code. Maybe not every single line, but every single section. So what I've done at the very top of mine, let me go to the top, is I've said PS, so please note. Don't know why PS is please note, but hey, let's make this red as well so it stands out. Please note, the screenshot comes first and the explanation of the code goes under it. So for every single screenshot that you see, the text under it explains what's happened. So it's very easy to follow. So I scroll down, I can scroll anywhere and stop and say, okay, this part here, this image here, this is the explanation for what's happening there, right? So that's it. Hopefully that was useful. This is the end of activity. Oh no, it's not the end of activity 4. The final thing to do, let me scroll to the very end. I'm gonna do this. I'm gonna say code. This is call this part full system code then. Maybe full system code start. And then maybe full system code end. I'm gonna paste my code in here. Let's make this one red and bold. Let's make this one red and bold as well. So bold and red. And in here, I'm going to paste my code. So I'm going to come back to my funny again. You could scroll to the very top or very bottom and highlight every single line. That's going to be a bit long for me. So again, the shortcut for this is press and hold Control on your keyboard. So that's CTRL. Then you tap the A key. So A for alpha, press and hold Control, tap A. It highlights everything for you automatically, right? You can do right click and you can do copy, or the shortcut for this is also CTRL, so Control again, press and hold Control down on your keyboard and simply press C for copy. That's copied everything for me. I'm going to go back to my Word document here, and all I'm going to do, I can right click and choose paste, that one there, or for me again, shortcuts all the way. I'm going to press and hold Control again and tap V for Victor on my keyboard, and that pastes everything inside there. So this is every single line of code that I've written, every single line of code in my system. You might want to do this maybe in a different way, but I think this is probably perfectly okay. And the reason this is okay, again, we're submitting this as a digital document, so you don't really have to worry about how long it is. This is why you must, I will show this as well, you must export your Word document as a PDF so stuff doesn't move around. Every single person that opens a Word document, it looks slightly different on their PC. Some people might be using a Mac, some people might be using a phone, a tablet, a Windows PC, it will look slightly different. Whereas a PDF, things are fixed. They don't move around. So make sure, please ensure that you export as a PDF. I will show this process as well. But I think this is the end of my activity 4. Please pause the video and read what you need to read the explanation if you need to read it. I don't want to read the entire thing. It will make this video way too long, and it's too long already. So thank you guys for watching, and hopefully that was useful.